We are here at the bottom of page 2 for section 1.6, the notes. And at a certain point in the assignment, you'll hit a couple of problems, just a couple, where the instructions read like this. Identify the terms in each algebraic expression. And here's a great chance for a recall opportunity. In other words, if you don't remember what the word terms means in an algebraic expression, now's your chance to learn it real quick. We talked about earlier in the chapter that these are pieces of the expression. An expression meaning there's not going to be an equal sign here. Okay, we're not trying to solve anything. We're just trying to look at the expression itself. Algebraic means that there could be variables involved. So they're pieces separated by addition. And we've been talking about all along, and now we're really in the section that underlines it here. Terms can also be separated by subtraction, but the reason that the definition says terms in an expression are pieces that are separated by addition is because subtraction is really adding the opposite. So subtraction can be written in form of addition, so that's why you can have, that's how you can identify all the terms of the expression. So there's a couple problems in there where all they want you to do is list the terms. Then they move on to where you actually simplify each algebraic expression. So what you've done is, like at the top of the page, you did everything with numbers, fractions, decimals. We had that one little hint of a variable situation when we threw in pi, because technically it's an unknown in the sense that we don't know the exact amount of pi. The decimal never repeats, it never ends. But now we're truly going to be throwing in some algebra where there's letters, and there's no hint to what those letters represent. They are variables, they're unknowns at this point. So I'm just going to combine both of these instructions into one problem, but know that there's going to be some separate problems where you identify the terms in the algebraic expression, and those are all the pieces that have adding in between. And for subtraction, change the subtraction to adding, and then you'll be able to identify all the terms. Okay? And important to do this because then you get the sign attached to the term correctly. Okay? So let's look at number 80, and we've got, always helpful to read it out loud, and for you, copying it too onto your paper when you're doing the assignment. Move from book to paper by copying it word for word, letter for letter as you go first. 5 minus 7b minus 13 minus 4b. Okay, let's start by being able to identify the terms, which means we need addition separating each piece, which is what we were going to do anyway, dealing with subtraction, change it to adding the opposite. So minus the positive 7b is going to become plus a negative 7b. Minus, and I guess we just started with a 5 here. And then minus the positive 13 becomes a plus a negative 13. And finally, the minus the 4b, which is really minus a positive 4, becomes plus a negative 4b. And now we are able to identify the terms. So over here, when it says, if this was the problem that came under these instructions, identify the terms, what you would do at this point is you would say, okay, the terms are 5, comma, like you're making a list, negative 7b, that's another term, negative 13, and negative 4b. Those are the terms. That's all they want you to do in that one little set. I think there's maybe 1 or 2 problems where you have to identify the terms in each algebraic expression. So that's an example of how to do that. Now I'm going to continue on in this problem to follow these instructions where it says to simplify the algebraic expression. And in that case, we are taking care of any parentheses and combining like terms. There's no parentheses in this one. So our next step is to combine like terms. So to simplify means remove all parentheses or any grouping symbols. Sometimes you do that just by identifying, oh, it's just a placeholder, or it just means multiplication, but sometimes it does mean distribution. depending on what you're given. Okay, you want to be able to get clear on what the symbols are telling you. It also means then to combine like terms. That will get you to the place of having it simplified. It's a big question I hear all the time. How do I know if I'm done? If all I'm doing is simplifying and I'm not trying to get an answer, I'm just simplifying, how do I know I'm done? Well, if you've removed all the grouping symbols and you've combined like terms, you're good to go. For our purposes right now, that's what will get us there. The other thing the instructions say is simplify each algebraic expression so we can expect variables or letters, and also expression means there's not going to be an equal sign. We're not trying to solve anything, okay? We're just trying to combine things into a simplified form. It may not look any simpler, sometimes they do, but as long as you follow these 2 steps I've written here in green, you'll be good to go. Okay, so now we definitely want to use our properties here, because as I look left to right, 5 plus a negative 7b, those are not like terms. I cannot combine them. 7b and 13 not like terms. It's 7b and negative 4b are like terms. So that's where we want to put our focus in, is reassociating this, rewriting this in an order that makes sense. Okay, so I'm going to rewrite this as 5 plus a negative 13 plus the negative 7b plus negative 4b. Okay, I'm going to rewrite, and I can do that using the commutative property. Okay, commutative property of addition if you want the official title. And then we can take it left to right here, because we've got like terms grouped together here. 5, then we can do like terms, and that's because of the associative property. We can group together what we choose, because again, it's all addition here. We've got adding, we've got adding, we've got adding. Okay, I'll go ahead and mark this 5 out in front with a positive so we don't have to wonder. It's positive, positive. Okay. So knowing what we know about positive and negative numbers, the signs here are different. One's positive, one's negative, so we're going to subtract. 13 minus 5 gives us 8. And we're going to keep the sign of the bigger number here. I'm going to use yet a different color. I'm going to keep the sign of the bigger number, so this becomes negative 8. Okay. I bring down my plus. In between those two, because associative property, I'm going to take care of the group that makes the most sense to me. In this case, constants and the ones with the variable b, so like terms here. I've got a negative and a negative, so like term, or same signs. I'm going to add these together. 7 and 4 make 11b, and again, I'm going to keep the bigger sign. It's the same sign, so it's not going to matter, but it lets me have that same rule whether the signs are same or different. So I use that, keep the bigger sign. And then finally, we look at can we take this any further, and you've got a negative 8, a constant, no variable in front, and then a negative 11b that has a variable. You have to have exactly matching variables and exponents of the variable to be like terms. You cannot combine this any further. Okay, it can't be simplified further. So it can't be combined further. So our final answer here is negative 8 plus a negative 11b, or if you want to write that as negative 11b plus a negative 8, or you could also write it as negative 11b minus 8. Any one of those would be fine. Sorry, I took up some space there. Again, I get the question, well, which is more correct? They're all correct. You want to get to the point where you can recognize that these 3 statements that I just wrote, whether the 11b or the 8 term is in front or back, as long as you keep the signs attached to each term correctly, you're fine to switch them around the addition. Also, you can rewrite adding a negative as subtraction. That's just undoing what we did in the first, to rewrite subtraction as adding a negative. So typically, this is where a lot of mathematicians land, especially in Math 60, because we will want it in this type of form where the variable piece comes first, followed by the constant, to identify our important points are important pieces of linear equations, okay? But for right now, if you have any of these three versions, that would be considered correct. You would get the same point on the exam. Okay, let's look at number 82 here. Read it, see what we've got. 15 minus a negative 3x, parentheses are just saying, hey, look at me, I'm a negative, plus 8x minus a negative 10. So we're simplifying still. Keep in mind what the goal is. We're just simplifying. We're removing parentheses. In this case, the parentheses are just highlighting the fact that I have negative numbers. You've got multiplication here, negative 3 times x. Because I don't know x, I can't perform that multiplication. Okay, so in this sense, our removing, in quotes, of parentheses is just going to be to make sure we identify this term as a negative 3x and the last term as a negative 10. Then we're going to look for like terms to simplify this. So I'm going to start by identifying every subtraction and rewriting it as adding the opposite. So I'm going to start with 15 here and bring that straight down. Really, it's positive 15. And then I'm going to change this first subtraction to adding the opposite. So in this case, instead of subtracting a negative, we're going to be adding a positive 3x. And I don't need the parentheses anymore because I've identified clearly with a smaller kind of up top superscript what the sign is. So I can clearly see where I'm adding and what represents a sign. And then I've just got addition, so that comes straight down, adding an 8x, adding a positive 8x, just to make it super clear. Then we've got subtracting a negative, so we're going to add the opposite here. Once again, so we're going to add a positive 10x. Oh, I'm sorry, just 10. Got excited. Positive 10. Now, same thing as before, I'm looking to combine like terms. I see a 15 and a 10. So I can reorder this because now it's all addition. I've got 4 different terms. If I were to identify my terms, like it said in the previous set of problems and instructions, my terms would be 15, comma 3x, comma 8x, comma 10. They're all positives here. Okay, that's kind of nice. So let's you can do this any way that helps you the most. I'm going to use the associative property first and say, hey, I'm going to deal with these two like terms that are really next to each other, kind of set up, ready to go. So the associative property says I can do these two first. So I've got same signs, positive 3x plus positive 8x. So I add those together to get 11x. Keep the bigger sign, that's a positive. And then I bring everything else straight down. I've got a positive 15 plus the positive 11x. I've got at the end adding or plus a positive 10. Now I can use the commutative and reorder this, the commutative property, and I'm going to switch around the 11x and the 10 around this plus, but I take the signs with them. Okay, so this becomes a positive 15 plus, I'm just going to switch them around this other adding sign here, and I'm going to bring the positive 10 and the positive 11x. The reason why I switched that is because I'm interested in combining like terms here. In this case, the constants, 15 plus a positive 10, that's going to give you same signs, both positive. So I add those, 25, I keep the bigger sign, which is, in this case, they're just positive. So I have positive 25 plus a positive 11x. Can't go any further. This is as simplified as it can go. All parentheses are gone, all like terms. I've got a constant, no variable, and I've got a variable here of x. So these cannot be combined. Okay, so this is my final answer, or I could write that as just plain 25 plus 11x without the extra positive signs, or I could switch that around and put the 11x first plus the 25. Again, is one better than the other? At this point, no, there's no better, okay? The tendency is to kind of land in this last place just because this format where the variable comes first is going to help us later on in Math 60. But that doesn't make any of these less right. As long as you've got both terms are positive, you've got them being added together, you've got 25 and you've got 11x, I will accept any of these three versions as correct when we get to exam time. Okay. All right, write down what you saw and heard, make note of any questions. And just here's another thought as you are preparing for exams. We're in the last stages of completing chapter 1, so our first exam is on its way. Check the calendar for the exact dates. The more problems that you do and the more you can show on the paper, the more comfortable you're going to get, the quicker you're going to get to that level of confidence, that quicker you're going to get to the consistently right answers. And at that point, when you've gained confidence and consistently right answers and no look of the problem throws you off, okay? When you look at a problem, it doesn't catch you by surprise, right? You can just confidently say, hey, I don't care what it looks like, I know the steps to follow. Showing this, how do you get there? Well, showing the steps and all the easier problems that came before it is going to get you to that level of confidence. Then when you're at that level of confidence, that's the green light for showing less work, but you'll still be able to remember how to do these problems long term, which is code for you'll be remembering how to do them when the exam comes. All right, here's one to try. Number 84, hit the pause button until you get an answer, and then you can compare it to what we have. And answering this one, you should have gotten 6y minus 10x, or if you want to put the x first, it would be a negative 10x plus 6y. Okay, I will see you on page 3.